Hello，你好，同学们。OK，我是来自 SS Education 的属性。So 呢，接下来的这些影片呢，我们会收录在这里，so 你们可以无限的观看。我们之前做的这个 SPM 考试攻略。OK，我们是来自 SS Education 的升学辅导中心，都是提供一站式的免费升学服务。So 呢，如果是讲你之前还没有了解过我们的话，你可以通过 subscribe 我们的这个 YouTube、Facebook 跟 Instagram，就是 SS Education 可以了解更多的。然后如果是说你对升学很迷茫，想要了解更多关于就是 SPM 啊、UEC、Diploma 或者 Degree、PhD 过后的这个升学管道怎么样的话呢，你可以PM 我们 ，OK， 所以我们会安排就是辅导员跟你1对1的升学服务。OK， 话不多说 ，OK， 你们现在可以观看了。好，谢谢你们。
Will use the answer given and so on. So some student will ask, can I use formula? For example, like this question. Okay, momentum. Momentum in your mind, you know that is P equal to mv. So, all right, for SPM level, we cannot write formula. Cannot, no way. You cannot write formula and then you say, oh, P is pressure, P is momentum, M is mass, V is velocity. Cannot, right? SPM not allow this. So if you want to define it correctly, of course, beside those, like example, velocity, you will say rate of displacement change. Okay, that one you got definition already, right? You got the words for it. So for certain equation, certain terms, we will define them according to the formula. So when you use the formula, we cannot just say mass times velocity. Cannot. You have to use this. If they are multiplied, you will say product of mass with velocity, right? So this is the way how you write the answer for definition. Okay, all right. Okay, so remember we cannot use is mass times velocity. No way. You have to write product for multiplication. So if let's say the one that you have for example, like density. Density is mass over volume. Then how you cannot use the simple words like mass over volume like that. So we will use ratio. If you got per fraction one means you use ratio, right? So this is the way how you do it. Okay. Then for the first calculations, right? Okay, what is the momentum of it? P equal to mv. Mass is 78,000, and then velocity is 4,600. Okay, so when you come to this answer, you press calculator. Of course, everyone will get the answer is this. Okay, I just write the answer for you. All right, don't forget the unit. Right? Okay, so this one usually we will not give you marks because they're more than 100,000 already. 100,000 means what? The one that are underlined with red color one, if your numbers is within this number, you don't use standard form, they will be fine. But when you have more than this, you're supposed to use standard form, right? So this is the correct one, and this is not the correct one. So using standard form, when you have more than 100,000, right? And then the number of decimal point, you can put 3, okay, or 4 figures, no problem. Okay, right? So this is one of the questions that always students will ask, teacher, how do I know how many decimal point I have to put? This is the way, right? Okay. So what happened to the velocity of the rocket if the mass increase? Okay, so definitely your velocity will decrease. So when you say decrease, right, I will prefer you to write velocity decreases. Don't just say decrease. Make it more perfect. Velocity decreases, right? The reason is because your object is heavier already, then your upward force will become less. Upward momentum will become less. That's the reason. Okay, so this is the first part, first page. Okay. All right. Okay. Okay. All right. So since we have done with this one about the momentum, so here also I got some things to remind you. Okay. in momentum, what are the things that we actually have for your study part? Okay, when you come to momentum, don't forget principle, conservation of momentum. Okay, so not only this involved, you will have first one is elastic collision, you will have inelastic collision, okay, and then you have one more is explosion. Okay, so how you know which one is explosion, elastic or inelastic collision? Okay, for these two, elastic and inelastic collision, okay, the way is quite simple one. All right, collision must have something move initially. It means that before you collide, there must be either one moving or both moving. Same direction, different direction, doesn't matter. So for example, okay, this car, okay, here is moving, this one at rest. Yes, it can be collision. Or maybe this one at rest, this one move, also no problem. Both moving, also no problem. So as long as you have either one moving, there will be collisions. Huh? Okay, explosion is at first both also not moving, both also at rest. Okay, suddenly they move. That is called explosion. So the formula, I think that you all will be very familiar with that. M1U1 plus M2U2 equal to M1V1 plus M2V2. Right? While elastic, inelastic M1U1, M2U2 equal to M1 plus M2V because they stick together. That's why they will have the same velocity. Right? While explosion will be 0 equal to M1 plus M2V2. So this is the formula to calculate that. Okay? All right. So, okay. So for momentum things, you have to really know what is the situation that only your formula will be used correctly. So for collision, elastic, they do not move together. This one, they stick together. Okay? All right. Okay. So you can refer for it for a while. So usually, if possible, for all the calculation, you write the formula first. Then you will clearly know about what you should do and what you should not do. Right? What you should get first and so on. Okay. Then, right, question number C. Okay, so this is the table show the different rocket model. Right? Okay, you got PQR, one booster, two booster. Okay, and then density of the rocket. Okay, so you know that you want to move up. Okay, you want to move up with higher acceleration. Question got mentioned, higher acceleration. So it means that you have to push higher, push faster with more force. So definitely we will choose more booster and then low density. Okay, why? More booster, you produce more gas, okay, downward. That's why you produce more upward momentum. Lower density, you can reduce the weight. That's why the resulting force will be greater to move up. Okay, here a track. So even though here they already mentioned you have one booster or two booster. Okay, please don't write numbers. If they ask for this one, right, number of rocket booster, please write more booster rockets, right? Don't write one or two, write more, okay? Because we don't write number, we don't write figures one, we will write their characteristic. So more booster rocket. Okay, reason, produce more upward momentum. Okay, density of the rocket, it will be low density. Don't just say low lah, say low density. Why? To reduce the weight of rocket. So sometime, right, okay, student will say, in exam, when I write point form, my teacher give me wrong. The reason is because student use too short form. Low density, reduce weight. Your reduced weight, the weight is not specified for what. That's why you will lose the mark. So we will prefer you to write full things, reduce the weight of the rocket, right? Make your answer perfect so that they will have no chance to minus our marks. Huh? Okay, so this one is about the rocket things. Okay. So definitely the one that you prefer will be Q, huh? Right? Okay. So this one will be Q. Okay. All right. Okay. All right. Okay. So now number 8. Okay. So diagram 8.1 show the communications of the system that involve in the direct transmission of the EM wave to receive from the stations, right? Satellite to the station. Okay, so they ask you, what do you mean by electromagnetic wave? Electromagnetic wave, from here, you will have two things, electro and then magnet, two different things. So that's why when you define them, you will say the wave consists of electric field and magnetic field. Okay, this one not enough. You have to say that oscillates perpendicular to each other. Perpendicular to each other. Right? Must be like that. Okay. Then only you can get the correct one. Yeah. Okay. All right. Okay. Next one. Microwave has a wavelength of this one. The speed. Okay. For the electromagnetic wave, they all will travel with this speed. So remember, yeah, all of the electromagnetic wave, they travel with 3 times 10 to the power 8 meter per second. So that's why if you want to do any calculation, remember, this is the speed of all electromagnetic wave, this one. So V equal to F lambda, 3 times 10 to the power of 8 equal to frequency, I don't know, wavelength 3.0 times 10 negative 2. Okay, one more thing, right? I prefer you all, when you write the numbers, you write back whatever number they give to you. So for example, here is 3.0, you write back 3.0. Even though we understand 3 and 3.0 no difference, but it will be better you write it this way. So you get this answer. 1 times 10 to the power of 10 hertz. Okay? All right. Right. Okay, then simple. Okay, this one is not that difficult. Yeah. So in your chapter wave, right, the formula that we have is very limited. So I can write for you. Okay, first one for chapter wave, the formula that we have, the first one is V equal to F lambda. Number 2, period is equal to 1 over frequency, or frequency is 1 over period, also can, either one. And then next one we will have is for the refraction. This is for refraction, right? V1 over lambda 1 equal to V2 over lambda 2. This one is for refraction. And then after that, in your Snell law, we will have refractive index is speed of light in vacuum, by speed of light in that medium. Okay, psi I over psi R. Usually when I ask my student, if you forget the formula, you just write sine sana. Okay, all right. So angle of incidence the upper angle must be more than lower angle. The reason is because your refractive index is always more than 1. So in order to make them perfect, we will always put the larger number on the top. So D over D, what is that? Real depth divided by apparent depth. All right, so this is all the formula that you need to know in your chapter wave. And then after that, 1 over sine C. C is critical angle. Okay, don't forget this. And then one more formula, lambda equal to AX over D. This is the formula that involves your chapter wave. Right? So you can have a reference. You need to know all the formula that you got, so that when you answer question for formula, you will know what to use. Okay. All right. Okay. Second formula, this one. Period equal to 1 over frequency, or frequency equal to 1 over period. Okay. All right. Okay. When formula all in your fingertips, then you will know, then you will score your calculation easier. Even though calculation is not 100% or a lot of marks, but at least they will occupy at least 40 marks in your exam paper, yeah? Okay. Right, so this is the formula of it. Okay, right, C. Okay. All right, a transmitting stations in diagram 8.1 wants to build on the island, okay, in the state of Sabah. Give the reason, all right, of following choice. So for the wave, we will use microwave, okay, because it involves satellite. Okay, so first reason you can say high frequency, okay, or you can say it can propagate over long distance. Okay, or you can say not require medium, also can, right? But usually I will write the first one because high frequency. Okay. Okay. All right. Then here, frequency, of course, we will choose high frequency. Okay. Okay. Why? Because high frequency, it will give you high energy content. It means the wave have a high energy content. Okay. What's the reason? Because you still got learn this formula, right? The wave energy equal to Planck constant times frequency. So you can use this one to calculate the wave energy actually. Okay. All right. Okay. So, all right. Later we discuss this one about this. Okay. So, all right. The height of the receiver and transmitter. Okay. Higher positions, higher height. Okay. Why you have to place the higher position? Reduce obstacle. Okay. You cannot say no obstacle. We will better to say reduce obstacle better. Okay, so this one will be the way how we choose the stations for satellite transmission. So satellite, we make it easy. We always will use microwave because you have to pass the wave from Earth to the satellite. So in order to have a better transmission, we will use microwave. Okay, all right. So this one will be all the structured questions that we have. Okay, then the next one, it will be your essay question already. Okay, essay questions. The first question is quite. I'm not very sure, but usually my students here they also quite dislike chapter like because of a lot of drawing. So okay, let's see. Let's see what we can do on the drawing diagram. Okay, right. Okay, so diagram 9.1 show. Okay, if let's say I go too fast, you want to jot down, you just text me direct message, then I will put back the place because I do know how to speak over there. Okay, diagram 9.1 show the blind spot mirror. This one, small one. Okay, place on the side mirror. Okay, all right, to reduce the rate of accidents. Okay, what is the phenomena involve the formation of the image of mirror? So here they obviously already mentioned it is a mirror. So if it is a mirror, then hold on for a second. I screen a bit saying it already. Okay, so if it is a mirror, it will be reflections of light. If you use lens, it will be refraction. Right, so they got difference one. Lens is refraction, mirror is reflection. Okay, So, right, before we continue with part 2, okay, so in your concave mirror and convex mirror, right, concave mirror, sometimes they will give the name for convergent mirror, right, because they are going to focus the light. Hold on first. Now I'm going to share with you how do I remember them. Okay, all right. It will be better for you to learn how to draw the lens diagram so that it can be easier. Okay, yeah. All right. So I draw with the concave mirror first. Okay. So let's say my focal point and this one, each 1 cm. You must know that the distance of your focal length, all right, is half from the center. It means that here is 2 cm, focal length confirm 1 cm. Okay, all right. To draw the lens diagram perfectly, okay, remember, we have 3 lines. We have 3 lines. Sorry, this is convex. I draw wrong. Okay, I want a concave one. Okay, hold on. Okay, concave lens is this one. Concave mirror. Okay, so we will have 3 lines. Okay, look carefully. Line 1 is the line that you go parallel with the principal axis, right? Parallel, and then you go to focus point. This is line 1, right? Then line 2, terbalik from line 1. You go to focal point first, then you reflect parallel with the principal axis. It means this line that I draw parallel with the principal axis. This is line 2. Then how about line 3? Line 3 is from the center, you draw, hit on the center, they come back. It means that they go and then they return on the same way. This is line 3. So you need either one of this line to get you the diagram, right? So you have to know these 3 lines how to draw, because sometimes if they give you focal length and so on, then you can roughly figure out what you will have for your image. Okay, all right. Okay, so let me show you one diagram, one example. Then I can show you how do I determine the characteristic easily. Okay, so let's say I do back the same thing. Okay, focal length and center. All right. Okay, so first thing, let's say I got the object which is less than focal length. Okay, so I will use line 1 and line 3. Line 1 means you go parallel and then you go to focal point. Right? This is line 1. Line 3 from the center. Okay, how you draw line 3? You put your ruler on the top of the center and the arrow. Okay, then light hit here, hit on the mirror, and then reflect on the same way. This is line 3. So you will see that these 2 parts, they will form intersect point. The intersect point will be behind. So that's why I will extend the line until I met my intersect point. So this is the intersect point. Intersect point will show you one thing. Where is the image form? So here is the intersect point. Your arrow point up. This is the image. Okay. Now, how do we determine characteristic? Okay, first of all, you know that this is called upright, am I right? Because the arrow point up, image also point up. So they are upright. Your upright image always come together with virtual image. Upright confirm virtual one. Then you compare image and object. This is magnified because your image larger than object. That is magnified. Okay, so upright always come with virtual. Okay. Then one more diagram. Okay, I slightly draw a little bit. Okay, I show you first, then you will see which one do you prefer to memorize. Okay, So let's say this is my object. Okay, so I will use line 1. Okay, right, this line 1, hit the mirror and reflected. Line 2, okay, line 2 also can, right? Line 2 is you go to focal point first and then reflect. So you will get your image here. This is the image. Okay, so no problem. You draw image dotted line also can, or wherever, as long as you remember to label it. I for image, then will be okay one. Not label up. That's why usually I prefer you to label object image. So this one go up, one go down. This one is called inverted. Inverted image always come with real image. Inverted always real one. So this one compared to original, this is magnified because larger. So now here got one important thing. This one I got say upright always come with virtual. UV, right? Upright always come with virtual. So if your image form is upright, then confirm virtual image. Then if you have inverted image always give you real image, IR. So these two things a bit familiar, right? When you study electromagnet, UV light, infrared. So that's the way how I teach my student. With upright always come with virtual, UV. Okay, inverted always come with real, IR. Right? So this is the way how you remember. Okay, which one is which one. Okay, and then actually, if you say that all the 6 diagram, right, you want to memorize, it's quite difficult. I will prefer you learn the drawing. Learn the drawing will be help you much more easier than you go and memorize 6 different diagram and then end up each of them still got extra 3. So in other words, you have to memorize 18 properties. So what if you just learn how to draw? You learn how to draw, then you can determine the image properties easier. Okay, so this is the example that I will want you to know. Okay, right. So this one is about concave mirror. Later, I will show you convex mirror. Convex mirror will be quite different from concave because concave mirror got 6 different pair of properties and the object distance. But convex mirror, just one set only. Whatever you do, they will give you the same image properties. That is convex. Okay. Now, all right. Okay. So, convex mirror. Okay. Convex mirror, they will be a little bit terbalik like this. Okay. So I would like to draw. Okay, a little bit. Hold on. Okay, so this is your focal point, this is the center. Okay, for convex mirror, we also call them as diverging mirror because they are going to make your mirror diverge all the light, right? Diverging mirror, or sometimes we will call them as wide angle mirror. Wide angle mirror because they can measure very huge angle of reflection. Okay, so in convex mirror, only 2 diagrams you have to learn. That is 2 line only. Line 1, go parallel, and then, okay, here's the focal point. They don't convert to focal point, but they diverge from focal point. They go up. Like this. Go up from where? Go up from focal point. That is your line 1. Okay. I forget to label one more point. Okay. So this one will be okay. All right. Then line 3. Line 3. Okay. Second line. I say line 3. Okay. Second line, you will just point to the center. Okay. Here is the center. Okay. You just point to the center. Point to the center. and then reflect back on the same line. Right? So here is the image formation. Okay. So no matter what, you will find that for convex mirror, no matter where you put your object distance, near, less than f, equal to f, more than f, from whatever thing, infinity or wherever, they only give you one set of properties. All convex mirror sure produce upright image. Sure upright always come with virtual image. And they confirm is diminished, become smaller one. They won't be larger one. So this is the three properties that convex mirror confirm from. Right? Convex mirror, they are not like concave. Concave, they have 6 different pair, but convex, only one. Only like this, no other. Okay? One more thing, got student ask, teacher, the extend line you use dotted? Yes. For extend line, I usually use dotted line to show the difference. Okay? So this is your convex mirror. Okay. So you see, the way to draw concave and convex, they are different. Okay. Convex is always like this, no matter what. But concave, they got multiple, you see, different position of your object. They give you different image. So that's why for concave mirror, better for you to learn the 3 line, so that in exam, if you forgot or you worry you write wrong, you just draw it. Very fast one, you see, I just use less than 1 minute, I already know what is my properties of the image, right? So I just remind you, inverted always come with real. Upright always come with virtual image. But for convex mirror, confirm, no matter what your object distance, this is the only thing you got. Okay? Alright, you can check out first. Okay. Okay. Right. So this is the way that how I determine it. Okay. So this is about the mirror. Okay. About the lens, I can discuss with lens with you also. Hold on. Let me read the question first. Oh, okay. You want me to show you the lens one? Can. No problem. Give me a second. Okay. So this is for mirror. Okay. Lens, convex lens. Okay, we go for convex lens first. Okay. Convex lens also named as converging lens, because we are going to focus all the lens together, all the light together. Okay, so for convex lens, I also have to advise you, okay, principal axis is important, and one more, this is the lens. This is the lens, right? Okay, so we don't need to draw the full thing. You just draw like this will be fine. This is convex shape. Concave shape, I show you afterwards. Okay, so I will need your focal length on the both sides. Okay. So for convex lens, they are like concave mirror. They got 6 different pair of the image properties one. So that's why if you put different object distance, your image form are also all will be totally different from each other. So that's why the best way is you learn the 3 steps. Okay. Alright. So the line 1, go parallel with the principal axis and then go focal point. This is line 1. Okay. Then line 2 terbalik from line 1. Go parallel first. Sorry, go focal point first, and then only become parallel line. This is line 2. Right? Okay. Line 3 more easy. Right? You just put your ruler. This is the center. It can be like this. Line 3. Or it can be like this. Or it can be like this. So as long as you pass through the center, the light just goes straight. That is line 3. Right? Like this also can. Like this also can. Right? As long as you pass through the center, you just go straight. This is your convex lens. Okay? So I show you some example. Then later you have more clear idea about how we apply them. Okay, I draw 2 for you. Okay, all right. So you see the way, okay, this is the convex lens, the center, right? The convex lens, the center. Okay, so let's say my object is here. Okay, my object is here. So you can use line 1, go parallel, and then go focus point. Line 1. Then, okay, line 2, I don't say no. You go to focal point and then you go parallel. But then I prefer line 3 because line 3 is easier to draw. How? You put your ruler above the arrow and the center, like this. Okay, so intercept point is over here. Okay, so you draw up from here, dotted line. Okay, this is the image. Okay, so one up, one down. This is inverted. Inverted always come with the real image. Okay, image compared to object, image larger. So larger, don't use larger, use magnifying, the best word, magnifying. Okay, all right. So this is the first diagram. Okay. Then how about if I got another object which is like this? The object less than focal length. So line 1. Then line 2, line 3. Put your ruler on the arrow and the center. Line 3. This line 3. Right? This line 1. So to be the best, you see that here won't have intercept point. The other side, intercept point. So you extend the line. So here intercept point. Intercept point here, so you point up. Okay, point up image. So both also upright. Upright image come with virtual image. Upright always virtual. And your image greater than object, then this one is magnified as well. Okay, so this is the way how you draw the lens diagram. So of course, lens, this is the 3-step, right? You master the 3 lines, you can draw any lens diagram as you want. So that's why it's quite simple. Okay. All right. Okay. The last lens diagram will be concave lens. Concave lens also named as diverging lens. And you found that all the diverging diagram, right, they will do the same thing. I draw first, I show you. Okay, so, all right, for diverging lens, okay, I do the same. This is my lens. Okay. Concave lens, I will draw like this. This is concave, right? Concave pattern. Okay. Convex, round is a curved one. Concave will look like this. Okay. So whatever position you put your object, you always have line 1, Okay. Until this part, what they do, they will refract from focal point. This is line 1. Right? From here, they go up. You see, concave, they go down, go to focus because they are converging lens. Concave lens, they diverge because they are diverging lens. So they diverge from focal point. This is focal point. Okay. Then second line, same like the convex mirror one. Pass through center, go through center. This is your second line. No other already. And you will find that your image is always formed at this position. So they always upright, they always virtual, they always diminish. So, okay, to ask you memorize all of the 4 main diagram: convex lens, convex mirror, concave lens, convex mirror, convex lens, and so on, maybe will give you a lot of headache because you have a lot of things to memorize. So now I tell you, look carefully. Diverging, upright, virtual, diminish. These are also diverging, upright, virtual, diminish. You get me? So whenever you have diverging lens, then your image is always fixed like this. Okay? So this is the way that I can help you. So as long as you know, concave lens, convex mirror, they are diverging. So diverging, this is the properties of the image. Okay? While convex lens, concave mirror, no choice lah. You have to memorize, right? You have to learn how to draw the tree line. Okay? So this is what I want to share with you. Okay, so you can digest it first. If you got question, you can text in the box before we go to the question there. Okay. All right. Okay. Now, okay, simple. Okay. So now, like we go to the questions. See how they ask you. Okay. All right. Copy the diagram. Okay. To complete the light ray diagram of your image formation, okay, of the lens. Okay, so this is your mirror. Okay, like I will draw for you. Okay, so for concave mirror, you see, you only have 2 lines only, right? I teach you 2 lines, but this question they ask you for 1 more line. So how? Okay, we use line 1. Right, you go and then reflected from parallel line, focal point, sorry. Okay, this is line 1. In exam, you have to redraw, then all the focal length you have to put it yourself 1 cm, 1 cm each like that. Okay, then this one, okay, actually, I will suggest you to draw line 3. Line 3 how? Okay, you put your ruler on the arrow and then here. So the light hit direct to the sea, reflected back to the same direction. So here is the image form. So no matter you use the green line they ask, or you use the one that I show you, the line 2, also no problem. Okay. Okay. All right. So let's say if you still want them to do this one, no problem. How? Okay. Look at the line, the green line they ask you to draw. This line, usually I ask them to draw one, but if you want to learn, I can show you. Okay. You point to the focal point. and then reflect parallel. So this line you extend, the straight line, parallel line you extend. You see, intersect at the same point. So this is the line that you can use to draw for the concave. Okay. Yeah. So go green, focus on focal point, and then they reflected parallelly. This parallel line, reflected line, you just increase, extend the line. So until they intersect, you will get a point. Okay. All right. Okay. So what will be the image form? The image form, you know, is upright with virtual, upright, virtual, and diminish. Okay. Okay, simple, right? Okay. So 3 marks for the diagram. Each one line, 1 mark. Image formation, 1 mark. Like what I told you, some students will ask, teacher, do I need to draw the dotted line? No need. You just draw straight line and you label image, it will be fine. Oh, so you don't worry about whether they will lost mark because of you will use dotted line. Right? Most of the time they use dotted line, but doesn't matter. Don't worry. Okay? In exam, they will be okay with that. Okay. So now, okay, question C. Okay, it will be the selections once again. Okay. Your company was given the project to install the road safety mirror. When they mention road safety mirror, it means that you have to use the wide angle. Right? You have to use the wide angle. Because only this you can see the image from all the sides. Okay? Alright. Okay. So convex or concave? Right. Of course, we choose convex mirror. Because convex mirror is a wide angle mirror. Diameter, of course, as large as possible so that you can have greater surface to reflect the light. Okay, position, of course, high position. Why? Higher position only you can remove all the blocking. Okay, less obstacle block you. Okay, reflecting coating material. Okay, this one, of course, you see, among all, let's say you don't know. This one already hit 3. Of course, you will choose the strong one. Okay, so we will choose the strong reflecting because strong reflecting will make the light it will make the light become more reflective, and then you can form a clearer image. So this one easy. How do we write the final answer for the 10 marks? Okay, so just now you can write in table form, you can write in essay form, you can write in point form, okay, or you want to build a table to write all the answer also can. So first one, you will use convex mirror. Okay, convex mirror is used because wide angle. It is a wide angle mirror. Okay, all right. Number 2, diameter. These are wide angle mirror. Okay, okay. So big diameter to allow more light reflected. Okay. High position to reduce obstacle that block the object, right? Or the car. Block the car better, not the object. Okay? Block the cars, right? Block the vehicles, because you want to see the vehicles, road safety, okay. Then, okay, strong reflector to reflect more light to form clear and sharp image. Okay. All right. So after you choose, you choose and you explain already. So the last one, the last point will be KLMM. Which one? M is the most suitable. Okay. Why M is the most suitable? You have to give the reason again. Because using convex mirror, I will tell you how to score the 10 marks here. Big diameter, high precision, and strong reflector. Okay, all right. So, like here, now I highlight for you. First one, you say about convex mirror. Okay, then you say about big diameter. Then you say about high precision. Oh, then you say about strong reflector. Okay, so one choice, one reason. One choice, one reason, one choice, one reason. Here, 4 choices, 4 reasons, 8 marks. The last mark will be you choose M. You choose M, and then the 4 reasons. Convex mirror, big diameter, high precision, strong reflector. Rewrite back the choice that you put. 1 mark, and then the reason, the choices. Then you would use. Then you get 8 marks, 10 marks. No problem. You use table also can. You use point form also can. You use paragraph also can. No worry. Okay. As long as your sentence is a complete sentence, then the marks will be given to you. Okay. All right. Okay. All right. Okay. So got students say, teacher, if we use table, no problem. Can. All right. Allow. No problem. No issue. As long as you got write the answer in a perfect sentence, then everything will be just fine and good. Okay. All right. Okay. How about if teacher I erase all the number and then I form a graph, form a paragraph? No problem. Can. Right? Because in the mark scheme, they also will use point form one, right? So no issue with that. Okay, we still have one more part D. We finish the part D first. Only we go for a short break, toilet break. Okay, all right. So this one okay, So I would prefer you all. Okay, when you do this kind of choosing characteristic one, remember one choice, one reason. One choice, one reason. If let's say you blur, you try to use your common sense to find the correct answer. Okay. All right. What other factor can make the image sharp? Okay. First one, if you want a sharp image, okay, of course, your reflections must be good. For mirror, reflections must be good. And then usually another one which you have a large surface diameter. Right? These two will be the main one. Right? Okay. Of course, you will ask about teacher. How about the power? The focal length. Focal length will be adjusting your image big or small. Usually, the small image will be clearer one, right? Because the light more focus. So we can also say short focal length produce clearer image. Right? Short image, you can say that. Okay. So next one, okay. All right. Okay. How the image can be formed by the mirror. Okay, so this one is a convex mirror. So convex mirror, you want to explain how they form out the images. Okay, first one, all right, you must say that. Okay, okay. The light reflected from object, okay, point towards to the mirror. Okay. So we will say that the light first of all, the light hit on the object, all the object here, all the human, whatever things, then they reflect the light only, they go to the mirror. So when they go to the mirror, okay, that's one. Okay, second one, all right, okay, the light will reflect from focal point. Sorry, add one more word, sir. Reflected away from focal point. If this is a concave mirror, we will say the light will be reflected toward, right? Toward, that is concave mirror. Convex mirror, they will be away. Okay, all right. So images will form behind the mirror. So that's why all the mirror reflections, they are all virtual one, right? They cannot form on screen. You only can see. So 3 marks, one each. Okay. If the safety mirror is replaced by a concave mirror, what it will happen? Okay. So if let's say you replace with the concave mirror, concave mirror is a converging mirror. And some more, you see all of the things here, they are, of course, confirmed, they will be more than focal point. So more than focal point, okay, you can use diagram to draw. When you found that, when you use diagram to draw, you will see that all the images will become diminished and inverted. So this is the thing happen. And now, of course, you will say, teacher, how I know? Okay, no problem. Now is the time for you to show. Okay, so let's say, all right, this is the mirror, the concave mirror. So you can simply put focal point is 1 cm each, and then for sure, all the humans, all the object that show in the shop and so on, they are confirmed further than C. So further than C, behind C. So you can just put one object somewhere here, then you use line 1, and then you go focal point. Then line 2 or line 3, go focal point, go center, reflect back center. There's line 3. So here is the image. You see, all your image inverted and diminished one. So this is the way how we determine, right? These two answers, 1 mark each only. Okay, so I suggest you to wait. If you know that it is a concave mirror depends on your position of the object, and all the things shown in the shop must be further than your focal point. So further than your focal point, for sure it will be inverted, and then they are real image as well as smaller, diminished. So you can draw a diagram to verify the answer as well. So this one will be the last 2 mark. Diagram will give you mark, only these 2 will get mark. This one is only helping you to get these 2 answers if you need. Oh, more fresh? Okay, let's continue with this topic. All right, among the 12 topics, actually students hate the most is the electromagnet. All right, this topic. So I have to give you some brief idea. How do you use or determine which one is the correct hands rules you will use for determine the direction, this and that? Okay, I can give you a simple things up. All right, okay. All right, first of all, you know that we have 3 different hand rules, right? Right hand grip rule, Fleming left hand, Fleming right hand. Okay, so now I give you some idea first. Okay, if you have a straight wire or just one coil wire, this one you use right hand grip screw, right? Whereas the thumb is current, right? The finger is B for magnetic field, right? So I mean it's like that. Let's say this is thumb, right? So this is your current. This one will be your magnetic field. So for example, let's say if you have a current flow in this way, then how I know my magnetic field direction? Because it is a straight wire, so we use right hand grip screw. Okay, your thumb follow the current direction, then you will get clockwise. So the magnetic field produced in this way. So this is the way how we use the right hand grip screw. Okay. Somehow, if you have solenoid, we also use right hand grip screw, but they will a little bit different things here. The thumb will become north pole. The finger is the fingers are current direction. Okay, for example, let's say I draw one solenoid for you. Okay, what is solenoid? Your student will ask one. Okay, let me draw the solenoid first. Okay, my drawing is not good, so I just simply to show you. Okay, you know wire, right? Straight wire. Okay, when you make one coil, maybe it become like this. You make one turn, that's called one coil. The number 2 one. So when you take your wire, make many coil, it becomes solenoid. Actually, the difference is we can say like that. Straight wire, make one coil, make one turn. When you make many turns in plural, it becomes solenoid. So let's say, okay, you see, let's say the current come in this way, right? The current flow down like that. So which part of the solenoid will be north pole? You see, current point down. So current point down, this is solenoid, finger will be current. So your finger, same direction as current, point down. So when you point down, your thumb is pointing to the right side. So this is north, this is south. Okay, this is very important, right? You have to know it. Then only will be easier for you to know your Fleming left hand, right hand later. Okay, so this one is about normal electromagnet. Normal electromagnet, yeah. We haven't go to left hand, right hand yet. Okay. Okay. So, yeah, easier. Okay. Now, students will always have problem. Teacher, how I know I have to use left hand or right hand? Okay, simple. If you have, you have electric current. Okay, you want to use your electric current to move something, or you want to produce force to push something. This one will be Fleming left hand rules. Okay, right. Because you use electric current to produce the force or to move something. This one we call them as motor. Okay. In another way, when you have motion or you change something, you push something, or you move your magnetic bar in order to produce current. This one we call dynamo. So you can see a difference. Fleming left hand is you want to produce a force. You use electric to produce something to move. That is Fleming left hand. Well, if you have motion, like something moving, in order to produce induced current, this is Fleming right hand rules. Okay? All right. Now, okay. So maybe student will say that, teacher, how can give you easier way? Okay lah. I can say something simple way, more easier to understand. You look at the diagram. Got power supply or not? If you have power supply, you have battery, then Fleming left hand. No battery, no power supply, Fleming right hand rules. Like that, make it easy, right? The simplest way. Okay, what is induced current? Okay, hold on, later I will explain on the left side. Okay, you know current, right? Current, electric current, the charge moving, you push the charges to move one. Okay, induced current means you use magnetic flux, magnetic field to produce the current. It's called induced current, right? So a lot of our electric power supply actually they come from induction, come from this induced current. Okay, not like battery. Battery they are using chemical, right? So you have dynamo one, they are all considered as induced current. Okay, all right. Like okay, so this one I let you go through first. About Fleming left hand, right hand rules, this one maybe you can refer back to your notes about which one is the force, current, and magnetic field direction. Right? If you got problem, then the next week as our last lesson sections, you can ask again. Then I can show you immediately. Okay. Okay. Now, okay. So now you have a clear idea when to use what and so on. Now I use another example diagram to show you how the induction occurs. Okay, so look at this diagram. You have a trolley with a magnetic bar. So when you push the trolley move inside magnetic bar. When magnetic bar move in the solenoid, here you will have change of magnetic flux. Why? At first, okay, without magnetic bar, solenoid have no magnetic field one. So there's no current flow, that's normal. But when you let magnetic bar move inside, magnetic bar have their magnetic field. So magnetic field start to disturb solenoid. That's why they will have induced current. Okay, so like this. When magnetic bar go in, how do we know they produce current is clockwise or anti-clockwise? Very simple one. Okay, before this, no north, no south, nothing. Now the trolley go in. Trolley go in, this side will become opposite. When magnetic bar go in, you will against. Remember, you will against. So here is north, this side must be south. Then how do we know current flow in which way? Remember, solenoid use right hand grip rule. Here is north, the thumb is north. You point to north, your finger is up. So finger up stands for the current point up. So that's why you see here I enlarge a little bit. Let you see clearly how do I show the current direction. Okay, north is here, right? Then your finger confirm will point up. Point up means current go up. So current go up, follow the back wire, come up. Become like this. So they become one cycle. Okay. Okay. I repeat again. When you let magnetic bar come in, okay. When you come in, we have to against. So that's why here north, here will become north as well to against it. So when you against here north, here south, how do you determine the direction of the current is over here? North. Current point up because finger point up. Finger point up, current go up. Okay, so this is the way how I determine the current direction. Okay, so now the question one, what is meant by electromagnetic induction? Okay, the definition for electromagnetic induction, you must have this one. Okay, okay. Productions of electromotive force. Okay, electromotive force in short form we call EMF. Okay, when there is a change in magnetic field on conductor, right? The solenoid is the conductor. So you have a change of You have a change of magnetic field. That's why you produce induced current. If you have no change of the magnetic field, then you will produce one. Okay, so this one will be the part A. Okay, then all right. Based on diagram 10.1, okay, what will happen to the pointer of galvanometer when the trolley moves in? So this part, same as what I told you just now. 4 point. 4 point, you mentioned about, okay, when trolley go in, what happened? This one become North Pole because you got disturbed in magnetic field, change in magnetic field. So solenoid left side will become North Pole. Okay. Then charges will be induced, will be moved. They will produce current. Right? 4 point only. Okay. All right. What happened to the pointer? Okay. First thing. Okay. The pointer in galvanometer will deflect. Okay. One thing is deflect. Okay. 1 point. Second point. Okay. Then you explain why. Okay. All right. Okay. When trolley move into the solenoid, okay, magnetic bar will change the magnetic field of solenoid. Right, 1 mark, move in 1 mark, change magnetic field 1 mark. Okay, so right, charges in solenoid will move to turn P into North Pole and produce induced current. So this is the way how they get the 4 marks. So pointer deflect 1 mark, trolley move in, magnetic bar, change magnetic field. Must mention change magnetic field 1 mark. Then this magnetic field, when they change, the charges in the solenoid, they will start to move in order to make the P, this P, change into North Pole to produce induced current. Yes, you can write magnetic field lines are cut. Okay, cutting of magnetic field line, cutting magnetic flux, changing magnetic field, all can, no problem. So here I can change to magnetic field line. Okay, magnetic field line. Magnetic flux, they are the same thing actually, so no issue, no problem. Okay, all right, so this one will be the simple 4 marks. Okay, not much, but the explanation require a lot of your understanding about induction. Okay, all right. Okay, so far any problems that you have? For your level, there's no formula for you to calculate any induced current. You only need to know how to decrease induced current. That is, induced current increase when you move faster, use stronger magnet, more turns. That's the way. What does the deflected galvanometer look like? Okay, like this. This is the pointer, right? When the charge move from this side to the right, when they move, so they will deflect. That's the idea, right? Okay, when they turn into, when the charges start to move, this is called deflection. So the pointer here, they deflect, right? Okay. Right? Okay, like next one. Okay. Diagram 10.2 show alternate current generator. Okay, here I got one more thing to tell you about this further. If you see that the question gives you two slit ring, one slit ring is DC, two slit rings, it will be AC. That's the way how I determine that. Okay, one ring only, they produce DC. Two ring, they produce AC. Okay, all right. So the mechanism principle behind the dynamo, if you want, you can prepare. But I really do hope it come up because they want some mostly students cannot answer full marks one. They will sure lost mark one. Right? Okay. Like let's look at the questions. What do they want? Okay. So all right. You need to choose the one that produce the generator that produce the highest current, highest induced current. You want the greatest one, and determine which one is the most suitable. So of course, as I told you just now, the magnet must be strong. Okay, strong magnet. Okay, then you must have a concave, right, shape. Okay, why? Strong magnet, then you got more magnetic flux to cut, to change. Concave, because you can focus magnetic field in the middle. That's why you have more cutting. Okay. While number of ring, of course, more ring better. More ring, more cutting, more interactions. They produce more induced current. Then diameter, of course, larger diameter the better. Why? Larger diameter, resistance lower, current produced will be greater. That's the reason, right? So I think that you highlight all, you found that T is the most suitable. Okay, so what's the reason? Yeah, okay. First one, we use strong magnet. Okay, strong magnet always come with the word produce stronger magnetic field. But some students will say produce more magnetic line. I don't say no, can, same idea. Okay, you use concave shape. Okay, why? To focus magnetic line, magnetic field. Don't use the word focus, use concentrate better. Concentrate. Magnetic field at center. Yeah, at center. Okay, I draw the diagram, then you will understand what I'm talking about. Okay, this is the flat one. If you have a flat surface, the line just goes straight, like this only, right? But if let's say you got a concave shape, this is the concave shape. So the line will become like this. Right? So for example, my drawing is not that nice. So you see, this part will be concentrate. And sometimes we will call this one as radial field. Right? Radial field. Okay? Okay. Then more turns. More turns for what? More cutting magnetic field. Or you can say maximize the changing of magnetic field also can. So the main key point is you must mention either one. Cutting also can, changing magnetic field also can, cutting more flux also can. Either one way. Yeah? Okay. Then of course you must have a large diameter. Okay. Reason what? Lower resistance on wire, in wire. So greater current will flow. Okay. Okay. So among all, T is the most suitable. So remember, most suitable, you also have to mention the reason, because using strong magnet, concave shape. Rewrite the reason. More turns and large diameter. Okay, so this is the way how we write them. So, strong magnet, yes. Concave shape, then more big or large diameter, right? So 10 marks. Remember one more thing, two essay in your section B, please only answer one, don't answer both. If you answer both, only the first one will be marked, then you waste your time. They will not mark both and then choose the highest for you. They only will mark the best, the first one, and then that's the marks. So that's why not worth if you do all, but at the end, you don't have the marks. So not worth it, really. Okay. 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 Why resistance diameter larger, resistance will be lower? Okay. Do you remember that in your resistivity, we have one formula is about this one? Resistance is equal to resistivity multiplied length over the cross-section area. So large diameter is referred to large cross-section area. So larger the area of the wire, for example, this is small wire, this is large wire. So larger the surface, smaller the R. And you also can explain in this way. When you have a small surface area, small cross-section surface area wire, then the charge flow will be a lot of obstacle. But when you increase the diameter, make the cross-section become greater area, more charges can flow without obstacle. For example, traffic jam. If your lane is only one lane up, one lane down, easily jam. But if let's say you make the lane become like highway, 5 lanes up, 5 lanes down, then the charge will be flow fluently. So this is the reason, right? Larger diameter, the charges can flow with less obstacle. That's why they can flow easily. Okay. Okay. All right. Okay. Done. Like. All right. So now we are continue with the transformer formula. Okay. So for transformer, I will tell you a little bit about the principle. Then we go for calculations and also some important things. Okay. I don't know how about your practice. When I see the bulb got voltage, got power, in my mind, I will straight away P equal to VI, 24 equal to 12I. So the current is 2 ampere. I will do like this first, right? I don't know why. When I see power and voltage, I will straight away P equal to VI, then I get my current first. Okay? All right. Okay. Next thing. All right. For your transformer, actually the idea how the transformer actually functioning is you will here you must use AC. Remember, only AC can make transformer function. If you have DC, DC no function one. Why? Because transformer will need to let the magnetic field change. That's why you need to use AC. So the idea is like that. When AC pass inside your primary coil, they will produce electromagnet. Why? Current in solenoid, they will produce electromagnetic field. This electromagnetic field, they travel and they touch, interacting with the secondary coil. When the magnetic field interacting with secondary coil, here you will have changing in magnetic flux. That's why you produce the induced current. So induced current flow in secondary coil. That's how transformer function. So of course you say, teacher, step up, step down. How? Okay. When your secondary turn, this one have more turn than primary. More turns stand for more interaction, greater induced current. If you have less turn, less interaction, then the current become less. Okay, for example, you see, step up transformer is primary and secondary coil. Primary coil is like this. Very ugly, I know. Double result, nice then okay. Okay, you see, when you have it produce magnetic field, you see, so much of the coil interacting, of course, your induced current will increase. No? But when you come to step down transformer, primary coil, then secondary coil. So you see, when you produce so much of magnetic field, but the cutting one is only this one, so induced current less. So this is the idea how principal mechanism of your transformer actually happen. Okay, so you can have a brief idea, then we will proceed with the formula to our calculations. Oh, okay. Got student asked, teacher can briefly explain about the method how to increase efficiency. Okay. So right here. Okay, first one. All right. Okay, you will use thick wire in secondary coil. Why? Thick wire same as the cross-section area or large diameter. Reason? To reduce resistance. So current can be easier to flow. Number two, you will use laminated iron core. Okay. What is laminated? Okay. This is not laminated. Right? A box of iron core. But laminated means like this. The iron core, you chop them into small slices. This is laminated. So what's the function? You can reduce eddy currents. Eddy currents is one of the current that flow and cause you lost energy. So that's why you cannot produce greater interaction, greater induced current. So we have to use laminated so the eddy current can be reduced over here. Okay. Then the third one, you use soft iron core. Okay. What is soft iron core? Soft iron actually means very low percentage of carbon in iron. Very low one. Very low. Okay. So this one, okay, you can reduce energy loss during magnetism and demagnetism. Because when you flow electric current in the primary coil, you will produce electromagnetic field. Here, you will use energy because you convert electric to magnetic field energy. So when you convert energy, of course, they will have energy loss. But if you use soft iron, you can maximize the energy transfer. That's the idea. And then last one is, okay, you will use coaxial, right? Coaxial method to reduce leakage of flux. Okay. All right. What is coaxial? Okay. I draw over here. The blue one is the primary coil. Then the red one is secondary coil. So you put soft iron in the middle, and then you cover with primary coil, and then the secondary coil outside cover it. So this is the way how we produce the coaxial method. So coaxial can let your magnetic flux completely, right? Completely transfer. That's why you will not lose any magnetic flux. So this is the four way. How do we increase, right, the efficiency of your transformer? Okay. If you have low efficiency, means what? You use a lot of electric energy, but your output energy is very less. Then your transformer is no use one. That's why we have to increase efficiency. Okay, like let's go to the calculation now. Okay, so okay, so what is your output current? Okay, so as I told you just now, we will use P equal to VI to solve it. So 24 equal to 12I, your current equal to 2.0 ampere. Right, very simple. Output is referred to the secondary, right? So secondary, you have the bulb up here. So we use the bulb to determine the output current. Okay, how do we determine the input primary current? Okay, like this. The formula is very easy one. VP and P, VS and S. Okay, it's always voltage above, current below. Then how you remember that? Primary all on one side, secondary all on one side. Easy. So primary voltage is 240, number of turn I don't know. Then secondary, the voltage is 12. How you know? Do the bulb 12 and 150. Question given. So you solve it, 2 marks. You will get 3,000 turns. Okay. So what is your efficiency? This one will be a little bit too difficult to me. Efficiency will be equal to output power divided by input power multiplied 100. So what is your output power? Output power will be at your secondary coin. You have the bulb 24 volt. Then how you calculate the input power? Okay, input power, you can use P equal to VI. The voltage you got is 240, and then the current also given 0.125 ampere. So from here you get 30 watt. So over 30 times 100. So you get 80%. So this is the idea of your transformer. Okay? Alright. Okay. So you go through first. Any questions, let me know. Okay. When you ask for the scope for the exam, I only can tell you there's no perfect scope, but I can tell you that the topics that I discussed with you, there will be the scope from my part, right? So of course, I don't like others to list out what exam question come out this and that. I prefer to show you the example questions. Okay, so the last few minutes, right? I want to discuss about the way how you write MV, RV, CV, inference, and procedure. Okay, so all right. Usually, you have to determine the MV, manipulated variable. Is that important? Manipulated variable. Okay. This one usually is your factor. What changes there? Okay. Responding variable will be RV. Usually, this one will be a result. Right? Result. Then constant or fixed variable, we will call them as CV. Right? So it constantly no change one. From the beginning until the end, the same. That is CV. Okay. Now, if they ask you to write inference, the way we write is RV is depends on MV. RV in front. For example, the brightness of the bulb is depends the electric current supply. Right? RV in front, MV behind. The result depends on what factor. Okay? Then, if you have hypothesis, you must put MV in front, MV with direction, increase or decrease, so RV increase or decrease. For example, larger the current supply to the bulb will produce brighter light, right? Brightness is your RV. Okay, all right. Okay, so because some students also will worry that how about the experiment? Later experiment, I cannot write procedure, then how? Okay, so I can give you some guideline. For procedure, remember, procedure always need these four things. First one, you must have action, then you must have value, you must have apparatus, and direction. For example, okay, let's say that you want to study the density, right? For example, we give another easy example. Trolley and the acceleration, mass of trolley and acceleration. So, okay, action. All right, place two trolley together. Place is action, two trolley together. With what? With plasticine, your apparatus. And place on the inclined plane direction. Or maybe, okay, measure the volume of the, measure 50 cm cube volume of the gas with syringe, okay, and push forward. For example, you got a direction. Okay, or maybe you have the electric topic one. Electric topic one will be, okay, control 0.1 ampere with rheostat. Okay, so your procedure is always have these four things. Direction, sometimes you will have, sometimes you don't have one. For example, if chemistry, you will have a lot of direction. But for physics, usually these three things will be the main. What you want to do, what value, and what apparatus to use. So in your procedure, if let's say they ask you to sketch your, to write your procedure, because your paper 3, you have a chance to write your own procedure one. So they ask about what experiment, maybe you can study more about electric, right? Electric experiment. Okay, so the first procedure is always how you manipulate the MV. For example, connect the 50 millimeter diameter wire is connected with crocodile clip as diagram shown. Must be MV first. Then secondly, if you involve electric, you must close the switch or turn on the power, right? If you turn on the power, all right, depends on you use power or switch. Okay, if it involve electricity. So if the experiment got electricity one, you must mention this step. If not, you lost all the marks behind. Then third point will be how you measure your result. How you measure your result. Then the last point, you go for repeat experiment by replacing the MV, replacing 50 millimeter to 60, 70, 80 millimeter with CV, with the same type of wire, right? Yes, because we have three types: semi, half guard, fully guard, no guard. So very difficult to tell you which one is half guard and so on. So that's why we just prepare. This method, chemistry also can use one. Biology, I'm not sure, but chemistry is also used the same way, right? So this is the idea. Okay, all right. And then one more thing, the table. Okay, if you come to table, MV, RV. Make sure you cover your table. Cover like this. If not, you lost the mark. Don't forget, in your table, you need unit. Right? Like example, mass kilogram, you must write unit. Okay, so this will be some some method I can guide you for the procedure for chemistry and physics. Right? Bio, I can't, but this is the way up. Okay, so all right, so fast 6 o'clock already. Okay, so next week we will continue with the step 2, so you can prepare the step 2 notes, right, and get for SCS there. All right, so I think that this is all the sharing for today. Okay, so I will see you for the next week, the last lesson.
谢谢同学们的观看，记得不要忘了 subscribe、like、share and comment。我们下次再见哦。